Okay, intermediate algebra students, it's been quite a while since we've crossed paths. I've missed you terribly, as you know. But since we were looking at quadratic functions, we have to learn how to graph them. Now, I don't have my graphing calculator with me right now, and I think that's fine because we want to learn how to find all the important points of uh, the graph of a quadratic function. So let me just move this to the side for just a moment. So what we've looked at so far are things that have kind of looked like this. We know it's going to be quadratic because we have that x squared there. So we have that ax squared plus bx plus c. Now, this guy here, the coefficient on the x squared term, he is really the one that's in control. And that is, if a happens to be a positive number, your graph of a quadratic function is not going to be a straight line, it's going to be a parabola. If a is positive, it's going to open upward. If a is negative, it's going to open downward. All right? So he's really the one in control. I know sometimes you folks don't like it if the square term is negative. Don't care. Don't change the coefficients because you've changed the problem. And if you do that, your answer is not going to be correct. But what we're also going to be concerned with is this turnaround point. This is referred to as the vertex. So if we were to graph this on our calculator, and maybe I'll do another short video later, this is the lowest or the minimum point on our graph. This one is going to be the high point or the maximum point on this graph. Now, obviously, if we graph this on our calculator, we can figure this out. But there are a couple of ways of doing it algebraically, and I'm going to show you kind of I think the easiest way to do that. And that is quite often when you're talking about the vertex of a parabola, its location is indicated with an HK. And that is H is going to be your X coordinate, K is going to be your Y coordinate. And the way that you find H, it's equal to negative B over 2A. So if we were looking at our quadratic function up here, we know what A and B is right away from the function. Almost looks like part of the quadratic formula, because it is. And the y coordinate of the vertex is going to be the function evaluated at negative b over 2a. All right. Now, the other way that sometimes quadratic functions are expressed is in kind of the kind of a standard form for a parabola, is that sometimes it's written this way. And if it's written this way, first of all, this is the same a that I was referring to up here. It's the same a. But here you can tell right away where the vertex is, because as I said, the vertex is at HK. So, for instance, you have to be a little careful. This is an x minus h squared and a plus k. So for instance, if I gave you an equation that looked like this, say x minus 3 squared plus 5. So if we were looking at this and you say, well, where the heck is the vertex? This is x minus h. So h is going to have to be 3, k is going to have to be 5. Now, to figure out which way this is opening, if it looks like there's no coefficient here, we always know that we have that invisible, the invisible 1. A is equal to 1. It's going to be opening upward. But we can tell right away where the vertex is. Right? Likewise, if we had another function that looked like, say, 2 times x plus 1 squared and a plus 4. You have to remember that this is x minus h. So if you can't tell right away what h is, say, well, x plus 1 is equal to x minus h. The x's go. If you solve this for h, it would be a negative 1. And your k, this is k right here. So in this case, my vertex is going to be at negative 1, comma 4. All right, so let's just kind of keep those little formulas in mind. Let's take a look at our handout here. Some of these things we already know as to how to find x and y intercepts. Similar, way that we did when we were looking at things that were linear. All right, so if I'm looking at this guy here and I want to figure out where the intercepts are, the axis of symmetry. So our axis of symmetry, this is a line that's going to run right through your vertex because your graph should turn out to look symmetric about some particular line. So for instance, regardless of what we're graphing, if we're trying to find a y-intercept, we set x equal to 0. Likewise, if I wanted to know, well, where are my x-intercepts? So we want to know where's across this x-axis. We set the y or function equal to 0. So I would have 0 is equal to x squared minus 6x plus 8. This one happens to be factorable. So I have x minus 2, x minus 4. So my x-intercepts, I like an ordered pair always for intercepts. This is going to be at 2, 0, 4, 0. Now, in order to find the vertex, as I said, the x-coordinate of the vertex is negative b over 2a. So in this case here, negative b, or the opposite of b, is going to be a positive 6 over 2 times a, which is 1, so that h, or the x-coordinate of our vertex, is going to be 3. So if I want to figure out, well, what's the y-coordinate, we're going to take our function and we're going to evaluate this when x is 3. So that I would have 3 squared minus 6 times 3 plus 8. My goodness, what is this? 9. And 8 is 17 minus 18. Looks like k is equal to a negative 1. So that my vertex is going to be at 3, negative 1. Okay, so let's see if we can draw a little sketch of this. So I have x-intercepts here at 2, 0, 4, 0. This is up here at 0, 8. Now 3, negative 1, I have to kind of approximate. Looks like it's going to go there. And if you're one of my students, you know my drawing ability is extremely limited. Right? But this is not so bad. So this is supposed to be symmetric about the line that cuts right through the vertex. This is the vertical line here. That's the vertical line. X is equal to 3. And for those of you who are asking, yes, it is always the x-coordinate of the vertex. Now, one other thing I want to know here is, let's say if we were talking about domain and range. So domain, when you're dealing with a quadratic function, there's no limitation on what we can put in for x. We can put in anything we like. But the range, if we were to look at the graph here, you want to realize, okay, here's my vertex. This is at that 3, negative 1. Because we're opening upward, this is the lowest point on the graph. Lowest point on the graph. So my y values are going to start at negative 1, and they're going to go on from there. Okay. All right, so let's take a swing at another one here. So in this case here, y-intercepts at x equal to 0, so it looks like y would be 9. Now to determine my x-intercepts, I'm going to set the function equal to 0. And again, this looks factorable to me. So this 9, I think we're going to have to do the 9 and 1 combination. And I think it's going to be a plus x here and a minus x there. It may take you a minute to factor it, but this guy is factorable. So I get that either x is 9 or x is equal to negative 1. So my x-intercepts are going to be at 9, 0, negative 1, 0. Now, the other thing you want to notice about this particular parabola is I have a negative 1x squared. What that's going to tell me is this opens downward. It's going to open downward. All right, so let's figure out the vertex. H is equal to negative b over 2a. So negative b in this case looks like a negative 8 over 2 times negative 1. So that's negative 8 over negative 2, or 4. K is going to be our function evaluated at 4. So I have 9 plus 8 times 4 minus 4 squared. So this is 9 plus 32 minus 16. If we were to add that up, I think K turns out to be a nice round 25. So my vertex is way up here at 4, 25. All right, so let's see, 4, 25. Looks like I gave us a big enough scale to draw this. All right, likewise, let's see, that looks like negative 2. Here's negative 1. And over here, let's see, 2, 4, 6, 8, 10. I'm going to put a 9, 0 right there. And my y-intercept is at 0, 9, so we're going to kind of approximate this here. Okay, my graph came out a little bit pointy. I don't think that was any improvement when I went over it, but that's okay. But again, look what's happening here. There's my axis of symmetry. It runs right through the vertex. It is going to be the vertical line x equals 4. Okay, but again, here's my vertex. Does it look like the top point on the graph? This is going to be your largest function value. So again, if I wanted to know the range, domain's going to be all real numbers in this case. But since I'm up here at 4, comma 25, this is the highest y value on the graph. All of them fall below that. So my range is going to be from negative infinity up to and including 25. Remember, interval notation has to be in numerical order or it's really fairly meaningless. Okay, so let's just try a couple more here and see what happens. All right, so let me get my next page here. There it is. That's good. Now, this one here is kind of written in that slightly alternate form. That is the a times x minus h squared and a plus k. So let's figure out where the vertex is first. So it looks like a is equal to 1. This is x minus h. So if we can't tell just by looking at it, the h's cancel out, the x's cancel out, and if I was to solve for h, I'd get a negative 3. This is k over here, so my vertex is at negative 3, comma 4. So negative 3, comma 4. Now, I kind of put it on there for a reason, because the a is equal to 1, it's positive, my graph is going to open upward from here. Now, let's figure out our y-intercept. That's going to be when x is 0. So if x is 0 here, that's going to be 3 squared, or 9, plus 4, or 13. Okay, so let's see, 2, 4, 6, 8, 10, 12. I'm just going to put a pinch beyond that. Now, my point is, if here's my vertex and we're opening upward, does this parabola ever cross the x-axis? It doesn't. So where it says x-intercepts, I'm just going to put none. All right, so there's a point there. It's going to look something like this. And again, my graph should be symmetric about the line that runs through the vertex. Now, very common mistake here, and people try to find x-intercepts. Either put it on your calculator or stop for a minute and say, okay, can I really get x-intercepts here? My vertex is here, I'm opening upward, it's never going to hit this. For those of you who are a little bit more asleep, if you were trying to find x-intercepts, you would have something like 0 is equal to x plus 3 squared plus 4. If you try and solve this for x, when you take that square root, we're going to end up with complex numbers. We can't graph complex numbers. So we have to kind of, leave it as it is. All right, let's try just a couple more here. So this one here, let's figure out what we can. Y-intercept, that means x is 0. Y is equal to 5. Now, to find your x-intercepts, not everything is going to be factorable. This one kind of looks like it's factorable, but it's not. If the 5 and 4 were reversed, it would be factorable. But why don't we locate the vertex here? Let's see what's going on. This guy's going to open upward again. Let's find that vertex. So the x-coordinate of my vertex is going to be that negative b over 2a. Yes, I do write the formula a lot. I think sometimes it helps us remember what it is. So this is going to be negative 4 over 2 times 1, or this is going to be a negative 2. Now to figure out k, I'm going to evaluate the function at negative 2. So k is going to be a negative 2 squared. Please use parentheses. 4 times negative 2 and plus 5. I'm running out of room here. So this is 4 minus 8 plus 5, or it looks like k is equal to 1. So my vertex is x is negative 2, y is equal to 1. So negative 2, y is 1. We're opening upward. Here is my y-intercept. All right, so again, it's pretty close to the x-axis, but again, it's not going to cross us. So again, what I say here for my x-intercepts, we have none. And my graph should be symmetric about the line x is equal to negative 2. It's a vertical line, so it's always x equals something. And the x, what it's equal to in this case, is the x-coordinate of your vertex. All right, let's see. I think I just have 2 more here. So this one here, again, the first thing you want to notice is the squared term is negative. This is going to be opening downward. All right, so let's see what we got here. Y-intercept is at 0, 24. It's good I've got fairly large numbers here. Let's find some x-intercept. So I'm going to have 24 minus 2x minus x squared. And if I was to factor this, I think this is a 6 and 4 combination. All right, so let's see, that's 24. Negative 6x. What if I make this plus 4x would give me the negative 2x? So I get solutions of either x is negative 6 or x is equal to 4. So my x-intercepts are going to be at 4, 0 and a negative 6, 0. Okay, now let's locate the vertex. So I'm going to have something like negative b, which in this case is going to be a positive 2 over 2 times a, which is minus 1. That gives us an h equal to negative 1. K is going to be equal to our function evaluated at negative 1, which is 24 minus 2 times negative 1 and a minus a negative 1 squared. And if we do that arithmetic, again, it turns out to be 25. So my vertex is at negative 1, comma 25. All right, so let's see if we can graph this thing. And my axis of symmetry is going to be x equals negative 1. So I have an x-intercept at 4. I have another one at negative 6. I'm almost to 25 with my y-intercept. Now my x-intercept is negative 1, 25, way up here. Oh, let's try that again. Much better. Much, much better. All right. Okay, and again, if I was interested in the range of this function, it's going to be from negative infinity up to and including 25. Likewise, this one here, since my vertex at this one was at negative 2, comma 1, if I was interested in the range for this function, lowest y value is at 1. Everything is greater than that. All right, so I think I've got one more here on my list of things to do. So let's kind of move to the next page, see what's happening here. So in this case, we are going to have f of x is equal to 2x squared minus 11x and a minus 6. This is going to be opening upward. We can tell because the coefficient on the square term is positive. So y-intercept, we're going to let x equal 0. Excuse me, I said it correctly the first time. We're going to let x equal 0. Y is going to be a negative 6. Now, if I wanted to figure out my x-intercepts, again, this one does turn out to be factorable. We get something like 2x plus 1, x minus 6. So if I set each factor equal to 0, I get x is 6, and x is equal to a negative 1/2. Your x-intercepts don't have to be at whole numbers. They most definitely do not. So these are going to be at 6, comma 0, negative 1/2, comma 0. Remember, your y values are 0 because we set the function equal to 0. That's how we locate x-intercepts. Let the function equal 0, solve for x. To get y-intercepts, we set x equal to 0, and we solve for y. All right, now let's figure out the location of our vertex. So let me see if I can move out just a pinch. There we go. So h is equal to negative b over 2a. So h in this case is going to be a positive 11 over 2 times a, which is 2. This is 11/4. That's the same thing as 2 3/4, so we know kind of where to put it when we graph. Now, don't be scared of the fractions here because we can just take this. I would do it as 11/4, put it into our calculator, so that I'm going to have 2 times 11/4 squared minus 11 times 11/4 minus 6. Now, if we were to do this, we're probably going to get an improper fraction. I think it turns out to be like 51/8. If you're more comfortable with, a decimal, this is going to be something like 6.375, or this is also 6 3/8. So I'm more of a fraction person, so I might put this in as 2 3/4, and this is 6 3/8. Okay, now And our axis of symmetry, again, is going to run right through our vertex. It is going to be the x coordinate of our vertex there. So let's see what we can graph here. I have x-intercepts at 6, 0, and negative 1/2, 0. I have a y-intercept at 0, negative 6, so we have to kind of estimate there. Now my vertex is at 2 3/4. So let's see, there's 2, that would probably be 3. I'm just going to do it just shy of that. And a little bit below where my y-intercept is. I probably should have used a better scale for this parabola, or at least a little graph paper thing that's a little bit better, because this just kind of ends up being kind of wide and goofy looking. And I'll be honest, this doesn't look particularly symmetric, but you know, if you're my student, you know my drawing ability is pretty lousy. All right, so hopefully these examples explained how to graph a parabola a little bit better, how to find your intercepts, how to locate the vertex, because those are the important points of the graph. Thank you very much. I'll see you soon.